you've already heard of the legend, Lennard Wharton, and he will be the lead-off for this next session, number 4 in your program. Lennard, John, Munter, and me will be doing that, and then we have 2 video tributes, one from Song Kin, one from Dan Newhart. So here we go.
Okay, I'm going to need the clicker for the slides. I think our operator, the clicker for the slides.
Oh, the clicker.
The clicker. For a Klemperer. Right.
This is not me. This is what
Right. Since you can't possibly give a talk without a clicker.
Absolutely.
Right. Well, I've written my remarks down in part because I wasn't sure I was going to be here today. But the past 3 weeks have been rather exciting. I had shingles about 3 or 4 weeks ago in my right eye, and those seem to have resolved. And then earlier this week, I had a cardiac intervention, which was successful. And so I'm here on borrowed time, I guess you might say.
Well,
10 years of borrowed time.
yeah, exactly.
Right.
Wow.
Herodotus has talked about Croesus, the richest man in the world, and asked the Athenian lawmaker and economist Solon if he, Croesus, was also not the happiest person in the world. And Solon replied that you have to distinguish happiness from good fortune. And fortune can change, as we know in the case of Croesus. The happiest man that Solon knew had secured the admiration of his fellow men and the well-being of his offspring. And by Solon's values, Bill Klemperer was among the happiest in the world. And this symposium reflects the admiration of Bill by his fellows, and he was the father, grandfather, and great-grandfather of a great number of his scientific children, whose well-being is attested to the many advances and contributions to knowledge that they contributed. On the personal side, I must say, I feel like I was at either the Garden of Eden or the first milliseconds of the Big Bang when I became a student of Bill's. I was fortunate to be one of his earliest scientific children and was inspired by his friendship, his infectious memes, enthusiasm, curiosity, humor, irony, sympathy, hard work, persistence, and magnanimous ethics. He was a model of how a person can cultivate extraordinary gifts. And I remember fondly visiting with Bill and Beth and their young group of kids in their modest rental home in Cambridge when he was starting out, and many times thereafter. Again, there's going to be some contradictions here because I witnessed other memes in Bill's character when visiting with his father and mother, Paul and Margaret, in their country home in New Hampshire. And over homemade Viennese pastries, the discussion, believe it or not, included Freud and Moses and monotheism and totem and taboo, which to me appeared to be one of the great enthusiasms of Bill Klemperer, to the point where I purchased these books, and this meme has happily passed on to me. I know there are contradictions to that, which we've heard. And I'm going to begin this slide. Oh, you can see it now. with the back side was scrap paper of some sketches that I made in designing parts for our molecular beam apparatus. And we were pretty frugal in those days, so the scrap paper on the back of this was the proposal. And I think it appears to be Bill's first proposal for the molecular beam. And as I've highlighted in part, it was to obtain detailed knowledge of the structure of molecules and radicals which exist at high temperatures to further understand the nature of the chemical bond, a la Linus Pauling. I am sure this objective enchanted me like so many other people in this room. Several of my graduate school classmates signed up with the celebrated stars of the faculty: E.B. Wilson, Bill Lipscomb, George Kissigowski, and others that I can't even remember at this point. But I signed up with, I didn't realize the significance at the time, untenured Bill Klemperer, who at the moment had the most appealing ideas. And Bill was not afraid to ask questions of the best people in the field. And he took this neophyte, let's see, I'm gonna go forward, see if that works. No, maybe it's no, it's not working. Next slide, please. Oh, the wrong end, okay.
This guy there, does that work?
Yeah, that's right.
There you go.
Okay. I'm also bad with television clickers, too. But before we started it, at Chicago, the most famous expression for scientific research was from Enrico Fermi, who said that research is 85% procurement. And it's really true. And Norman Ramsey and Dan Klepperer and Bob Kolenko at Harvard were ones that we consulted with all the time. John Trischka at Syracuse, we actually went to Syracuse, Polycarp Cush at Columbia, and Vernon Hughes at Yale were people that we consulted with on this project. And he took us, this neophyte, to learn from the masters. And we were at the beginning of the space age, where stainless steel displaced glass or brass. And the Mallinckrodt Laboratory glass shop at that time was one of the best in the world. And the physics department really did not have the capability of handling the kind of fabrications that would be required, although they had some superb machinists. And so we had to use outside fabricators, and with heliarc welding, by the way, which they did not have. I don't recollect that they had it at the time at Harvard. And these are just some things that were part of these specifications. I have to say, E.B. Wilson, for example, who was one of the giants, had supervised Dudley, who solved the puzzle of the spectra of hindered internal rotations. But his experimental work was limited to the constraints of small budgets and limited capability of equipment. And thanks to massive increases in possible federal funding, Bill's, I guess the word is shovel-ready proposal, obtained more money for equipment than EB's long-standing ONR funding could ever have imagined.
I'm sure.
So we were able to build a physical chemist's molecular beam spectrometer. It needed different bones than a physicist. It had to be designed to measure many different kinds of molecules and had to be user-friendly. So we built the molecular beam electric resonance apparatus in the basement of Mallinckrodt. And this is a Klemperer story. I spent the first 3 months of my research ray tracing tracing the rays of molecules through those quadrupole optics, the A and B field, as was laid out in a paper by a group at Freiburg that Bill had apparently read. And he thought it was a good idea, quadrupoles instead of deflection fields. A group, Benowitz, Christoph Schlier, and W. Pohl. And after 3 months of doing these ray tracings, I came to Bill and I said, Bill, I don't think we have enough intensity from this design. To which he replied, okay, let's use sideways deflection. I'd assumed that Bill knew that the German quadrupole system would work for us. No, he didn't know that, proving to me that there's no such thing as omniscience. Soon afterwards, I discovered the Gaussian optic equivalent for the quadrupoles, which gave insight as that if we used a line source and a line detector, we would have copious intensity. One of the unknowns was the electric dipole moment of lithium hydride. And Bill had actually calculated the dipole moment based on classical ion polarizabilities, the polarizability of the chloride ion. And he came out with a dipole moment of about 4 dBs. And and we had to design our power supplies and all our equipment based on a small dipole moment. But as a joke, we inscribed mu, the symbol for the dipole moment, equals 6 dBs as a joke, which turned to be close to the results. And which actually had actually been predicted by some contemporaneous first principles calculations that were being done at the time. Now, these are some of the. This is the timeline, and it refers to something that Dan Klemperer had referred to in a kind of, I think, elliptical way. But we started in 1958, and it was until early in 1960 where the assembly was complete, and we had our champagne party based on testing a molecule of lithium chloride, and we determined the next day that the signal was false. So it took 3 weeks before we actually found a signal, and then we found out why. But Klepner and Klemperer had something in common. I think you've seen this picture of Bill, Peter Gold, and myself, and this was a Harvard University photograph, and the date of it is March 24, 1961, which is to the day 56 years ago.
Yeah, yeah.
Wonderful, wonderful.
So, and this is the machine, and it's what we say, it's more attractive view or something like that, without the principal investigators. Well, and these are the results, and that were first published. And I'll say one thing. I think some people said that Bill would always ask other people to get the job done. Well, the determination of a hyperfine structure from the nuclear spins, Bill did the calculations for that. He wrote, or someone stole, I don't know how he did it, the diagonalizing the Hamiltonian for this based on certain spin parameters. And then we had an argument, and he said, I can use a nonlinear least squares fitting algorithm to you don't have to test anything, just put in trial parameters, do the nonlinear least squares fitting, and you'll get the answer. And I said, no, Bill, it won't work. So Bill, being stubborn, he actually wrote a nonlinear least squares fitting, and it was fantastic. Now, while we were assembling this equipment in the basement, not the sub-basement, of Mallinckrodt, George Kistikowski, a man that seems to be coming everywhere in this drama, he would come by every 2 weeks. He was Eisenhower's science advisor and would come to supervise Bill Brennan, who was working with a Mark Ingram, a Chicago guy, glass copper mass spectrometer. And of course, without Kisty's work in Washington influencing the increase in government expenditures for science research, I'm certain that we could not have continued on our suicide mission. So this is what he said. Molecular
Never
beams.
saw that question.
He would come by and he would say in his Russian accent, "Molecular beams are the death of the chemist." and the reason for it was that he built the first supersonic jet. Oh, he tried to, and he and the idea of the supersonic jet, I think, can be traced to a name, Arthur Kantrowitz at Cornell, and a fellow named Gray. And Kissy tried to, that was a theoretical study, and Kissy tried to repeat it in the lab out of glass.
Well, he didn't have enough pumping power.
That's exactly. But other people like John Fenn found that it would work. And so...
Legend was that he smashed the apparatus with an axe. He was so upset about it. And I asked him if that was true, and he said yes, but of course, Kirsty might have won it.
He was a fabulous man. So let me just see what this next one is. Oh, yeah. I'll go back for a minute. So I'm going to finish with a couple of things that I know about his intellectual children and grandchildren from personal experience. And it has to do with a bunch of Klemperer characteristics or idiosyncrasies. We would drive in the Klemperer Cadillac, used Cadillac, to the Ohio State spectrometer in Columbus, Ohio. And he was obsessed with the importance of explaining the visible spectrum of NO2, which consisted of 100 million lines that was known since the time of Brown, the inventor of the Brownian motion, which is 19th century physics. They knew it had 100 million narrow visible lines. Makes it brown. And in theory, it shouldn't be that difficult to assign. It's only 3 atoms. And the best spectroscopists were struggling for 100 years to solve it, assign it. And to solve the NO2 puzzle was like proving Fermat's last theorem, according to, in Bill's mind. And through a felicitous confluence of circumstance, Don Levy and I and Rick Smalley had a discussion in Chicago of how our Chicago quadrupole state selectors could be used to simplify the NO2 spectrum by removing excited rotational state, removing all the junk, all the superfluous states that you can see. And I had reckoned that NO2's partition function was much too big. There wouldn't be enough intensity in the lowest states to matter. But fortuitously, Clifford Detz, a graduate student of mine, we had built a supersonic jet target for scattering experiments that seeded molecules in argon, a supersonic jet, and we found out that the rotational temperature from two-body collisions was a few degrees Kelvin. So I said, look, this supersonic jet, which is by the way, was based on liquid hydrogen cooling, which, I mean, you tell me, we had the president of this Cryogenic Society of the United States as our consultant for handling liquid hydrogen, and he would never have permitted that experiment in a million years that occurred with that oven. Anyway, we set up, they had, Rick and Don had the laser and the fluorescence detector, and we had the seated beam. It's the first experiment I ever made that worked the first time. And later on, we improved it based on a Roger Klemperer supersonic source, which, by the way, is a violation of the Dutchman approach to making satisfactory vacuums. Even if you have, and am I going on too long? Okay. There was an international conference in Toronto on rarefied gas dynamics in which a crazy French scientist named Roger Klemperer said that you didn't need these huge vacuum systems. You could get with a mechanical pump, and you could still have supersonic jets. And again, this is at a Gordon conference. I was sailing with a fellow, I'm sure a lot of you know him, Peter Tönnies. And Peter liked to sail, and I like to sail too. And we're discussing the Klemperer source. And Tönnies said to me, you know, I've tried the Klemperer source, and it works. So we used this, and this was the, it's a little bit, it's been a victim of Hurricane Sandy, but it shows, this is the beam external to an operating laser, the laser external, and it goes into a very small apparatus that's running at a micron pressure, and the upstream pressure is 1,500 psi, and so you have an area where the supersonic jet doesn't care that it's not such a great vacuum, and you can see the longitudinal modes of the laser. This is actually the spectrum of NO2. The second question that Bill posed to his intellectual offspring was the structure of compounds, chemical compounds in interstellar space, including carbon compounds. And in this case, it was a Bill grandchild whom I can attest to, Rick Smalley, and another E.B. Wilson child named Bob Curl, who was probably there at your time, Dudley, and Harry Croto, discovered buckyballs. They were motivated by curiosity of carbon chemistry in interstellar space. I mean, what could be of less importance to terrestrial being? And yet, buckyballs, I think, in my opinion, was a founding basis for the development of nanotechnology, which is here on Earth. So there you go, another example. I was not able to predict all the consequences of that dynamic mono, Bill Klemperer, but these are some hints as to what I saw at the early stages. It's been an honor to present these few glimpses of the world of Bill Klemperer as I admiringly remember him, and to share these memories with such distinguished company. Thank you very much.
Lovely.